Our 12th and the final assumption that I'm going to go over here is the assumption that the dv, the y variable, is continuous. Violation of this tends to be a real problem. And here's why. Just in my bivariate regression, if y is dichotomous, right, wins and losses, or some are boy and girl, or something like that, here's my problem, is that for any given variable of x, y here is actually just on this line. And then or it's on this line. Now, and you may have a couple of outliers, right? So we can get an OLS regression line, but that's not really right. This line is better described in this way, right? There's a sudden shift right here from 0 to 1. So this line is not very interpretable and not very meaningful for us, right? Because what is it? There's no like half of a win here. There's no half of a y. And so that tends to be a problem. We're unable to predict things properly when we do this. Now look, OLS regression will give us an answer. And that's true in most of these assumptions. We will get some sort of answer. The problem is that our interpretation of that answer is incorrect. And so in most cases, it's not giving us the best linear unbiased estimate of the parameter. Or even when it does, it's giving us standard errors that are not interpretable and to which we can't find significance. So this is why it's important to understand the errors. Because we will still, when we plug numbers into SPSS, when we plug numbers into R, it will spit out some numbers back at us that we will try to interpret. But if our assumptions are violated, if our DV is not continuous, or if our errors are related to each other, or if we have heteroskedasticity, or any number of the other assumptions that violate our assumptions of our OLS regression, then the interpretation of those results that we get from R or SPSS is suspect. And that's what we have to be careful of.